All right, here's another question from homework number 12. Let's take a look at this. It says the accompanying data table describes the results from the groups of 10 births to 10 different sets of parents. The random variable x represents the number of girls among 10 children. So just reviewing what a probability distribution is, and we're going to assume that that is. We would have to add up all these values and confirm that they do in fact equal 1. But we know they do in this case because the problem tells us that. So just a reminder of, like, for example, x equals 1 means the probability that out of 10 parents, 10 births, the probability of having one girl equals 0.012. Okay, and so on. And these are all the different possible, right? X is the random variable of number of girls. And out of 10 different sets of parents, the probabilities, all 10 of them could have boys, in which case there are 0 girls. There could be 6 girls and 4 boys, or there could be 10 girls and 0 boys, and so on. And I think here, because we see the probability of 0 girls and the probability of 10 girls is actually different. There's something at play here. So again, we are not given P or Q. We do not know these values. All right, so quick reminder of our normal distribution curve, and I'll explain in a minute. You'll see in a minute why this is important. Let's just take a quick reminder of what the normal standard distribution is. Okay, if you remember, this is where our mean lies, which it's just an x value. It's just a very special x value. X down here is the number of girls, right? And this is z. These are our z-scores. And at the mean, the z-score is 0. And we have 1 standard deviation above the mean. We have 2 standard deviations above the mean. We have 1 standard deviation below the mean. This is not perfect, but and we have 2 standard deviations below the mean. And if you remember, when you get outside of 2 standard deviations, that's when things start to get unusual. So when we look at the question here, we need to okay, here we go. Use the range rule of thumb to identify a range of values containing the usual numbers of girls in 10 births. So in other words, what they're asking us here is, what are these lines? Where do things start to get unusual? What are these 2 values of x? Because we know things get unusual outside of 2 standard deviations. So how do we find these values? Well, we have to know what 1 standard deviation is equal to for this particular problem. What is this width? How many births, how many girls is this width? So that means we need to find the mean and the standard deviation. And again, because we don't know P and Q, we're not going to use the formula. We are going to go ahead and use technology. So I'm just going to pull this problem up, and I'm going to click on Open in StatCrunch. Again, this is on your StatCrunch tips. You can click on Stat, Calculators, scroll down to Custom. We put our values in x and our weights in the probability of x. We compute that, and we have a mean of 5.031, and we have a standard deviation of 1.66. I'll carry it out 3 places. All right, so let's go back here and write that down. We have a mean of 5.031 and a standard deviation of 1.66. All right, so we can see, because this mean is a little bit more than 5 in a perfect, if the P and Q are exactly 1/2, 5 girls would be, the mean would be exactly 5 girls, exactly half. But it's slightly more, so P is probably ever so slightly above 0.5, above 1/2, slightly more likely to get a girl than not a girl. But again, for our purposes, we're using technology. So now we know this value. We know that 1 standard deviation is 1.66. And we now know the mean is 5.031. So If we know that this distance here is 1.66, and we know that we're starting at 5.031, let's go ahead and what is this first x here? What is this one here at 1 standard deviation above the mean? So we're going to just go ahead and add 5.031 plus 1.66, and that's going to equal 6.691. All right, let's add a second standard deviation, 1.66 again, because now we want to come out to here. We want to add another 1.66 because what we're concerned with is that 2 standard deviations away. And that's going to equal 8.351. So that is our cutoff. Anything outside of 8.3 girls starts to get unusual. All right, so that would be our maximum. It talks about what are use the range rule of thumb to figure out the usual value. So this is your maximum usual value. Anything below that, having 8 girls is still considered not unusual. Okay, and let's go the other direction. What is 1, 2 standard deviations below the mean? So again, we're starting at 5.031. This time we're going to subtract off, and I'm going to do it a little differently. 2 times 1.66. I'm subtracting off 2 standard deviations. So just go ahead and let your calculator do that work. And this equals 1.711. When I went back and checked, that's going to be your minimum usual value. That is your cutoff. We went back up here. Our 2 important numbers are 8.4. I'm going to change it to 8.4 because I did notice in the problem it says round to 1 decimal place. And over here it's going to be 1.7. Now you can't have 0.4 of a girl or 0.7, but that just means these are your usual value cutoff marks. So if I were to ask you, is the probability of having out of 10 families, is the probability of having 3 girls, right here, is the probability of having 3 girls unusual? Well, where is 3? We're at 5. So 3 is somewhere along here, right? So yes, this is still usual. This is still so yeah, that would not be unusual to have 3 girls. How about the probability? Is the probability of having 1 girl unusual? Unusual. Well, I would say, yeah, 1 girl is way out here. 1 girl, this is 1 girl here, 1 girl. And that is definitely in the unusual space, yes. All right. Another little trick you can always look at is over here. Remember, don't ever forget our 5% rule. We can even just glance right here and see. We need to go through all these exercises to find these exact cutoff points, which was in the question. But if you just had the question as P1 unusual, there's 2 ways to confirm that. One is yes, it's outside of 2 standard deviations. The other way is, look, it is less than 0.05. It's less than 5%. So therefore, that makes it unusual as well. Because remember, there was 95% of your people fall within 2 standard deviations. So everything outside of that is the remaining 5%. So anything less than 5% is considered unusual. All right, give it a try.